Welcome to Mission Evolution Radio Show with Gwilda Wiyaka, bringing together today's leading experts to uncover ever-deepening spiritual truths and the latest scientific developments in support of the evolution of humankind. For more information on Mission Evolution Radio with Gwilda Wiyaka, visit www.missionevolution.org. And now, here's the host of Mission Evolution, Miss Gwilda Wiyaka.
The world of math students has changed a lot recently. The focus on manual calculations was common in the past, but now we use calculators, apps, and AI. What effect are these innovations having on the skill set of the students? Have math teaching methods kept up with the changes, or do they need to evolve with the times? Mission Evolution Radio TV show is coming to you around the world on the X-Zone TV channel, xztv.ca. With us this hour to delve into the changing landscape of math education is Craig Hane. Craig earned a Ph.D. in math at Indiana University and then became an associate professor of math at Indiana State University and Rose Hulman Institute of Technology. In 2011, he founded the Triad Math, Inc., whose mission is to deliver an optimal 21st century math education to any teenage math student in the USA. Craig is the author of Dr. Dell's Golden Rule, Math for All God's Children, a 21st century math education for 21st century math students. His website, craighane.com. Craig, thank you so much for joining us on Mission Evolution.
Thank you for having me. My pleasure.
So, what was your early education in math?
I was homeschooled by my Uncle Jack Davis, who was a barber and a builder, and this was during World War II. I was born in 1938. I remember Pearl Harbor. And he taught me to count using Cheerios and then dimes and pennies. And when I was 5 years old, I could count, thanks to my Uncle Jack. And when I went to my first school, my teacher enlisted my aid in helping my fellow classmates who were older than me learn to count. And that was the beginning.
What prompted him to work with you?
Well, he taught me a lot of things. We lived out in the country. He had a log cabin and we had a little house near it. And he raised cattle and chickens. He taught me a lot of things. Math was just one thing. He was a builder. And he said, Craig, you need to know practical math to build. And first he started to teach me to count. Then he taught me practical geometry. How do you make a square angle so when you set a fence post and you use the 3-4-5 rule? And you do a third of a square angle when you're building and use the 1-2 rule and on and on. And he taught me practical math. He wasn't a math teacher. He was a builder.
But I'll bet that made him very understandable in a way, didn't it?
Oh, absolutely. And it taught me math that I could use and teach other people. And so I was teaching my classmates and my teachers math that he taught me. And so I wasn't very good at anything else, but thanks to Uncle Jack, I could do the math, and people admired that. Some people thought I was the smartest kid in the class because he had taught me stuff they didn't know, which is not true. I was just lucky and fortunate.
So I understand you were not doing so well in algebra during your freshman year. What changed that?
Well, yeah, we went into, I'm from Indiana, Greencastle, Indiana, and we moved out of the country in the woods into Greencastle when I was in the 7th grade. And then in the 9th grade, I took algebra at Greencastle High School. And I'd done well in math up until then because of my Uncle Jack. It was all practical stuff. And he didn't know anything about algebra. He was not a math teacher. And I didn't do well in algebra. I made a lot of careless mistakes. I didn't really understand it. And I didn't get a good grade in it. I didn't get an F, but I didn't get a good grade. And I was told by my counselor and my principal, Craig, you didn't do good in algebra. You're not college material. Just like no one in your family is ever going to college. You're not going to go to college because you did good in algebra. That was my freshman year. Now, I can go on from there if you want to know. What happened?
Well, sure. Then what happened? Now you've got me engaged.
My sophomore year, I had a geometry teacher, Miss Madonna O'Hare. She was a single woman. They call her an old maid school teacher, excellent teacher. And I loved geometry and I did really well in it because she was a good teacher. And so now I'm back feeling good again. Then I had my algebra again with the old algebra teacher. Now I'm a troublemaker because I'm asking him questions. How do you prove this? How do you prove? Why is this quadratic equation true? Where'd it come from? And his answer always was, Craig, don't ask that. Just learn it and do it. And again, I make careless mistakes. I've always done that. And I'd always make careless mistakes on my tests. And I didn't get a good grade again. So once again, you're not college material. But in Greencastle, Indiana, there's a college called DePaul University. And my geometry teacher suggested my senior year, I go to DePaul as a special student and take college algebra. And I had Dr. Clint Gass, who was the chairman of the math department at DePaul, in a college algebra class. He was a good teacher. And guess what? I got an A. And all of a sudden, I liked algebra.
And magically, you were college material, right?
He got me enrolled in the #1 liberal arts college in the United States. I didn't want to go to DePaul. I wanted to leave Greencastle. And at that point in time, the #1 and the #2 colleges, liberal arts colleges in the United States, coeducational liberal arts colleges, were Oberlin and Swarthmore. And he got me into, and I went to Oberlin as a visit. I loved it. I applied and he got me in. And I went to Oberlin College. They had an excellent math department. So I learned a lot of math, a lot of theoretical math. And then I taught, and by the way, I was tutoring all this time. I was tutoring students.
Mm-hmm.
And as a tutor, I never had a failure because it was always self-paced. Find out what they don't know. Make sure that you're teaching them the right order of things at their pace. I taught high school then, all 4 grades at Western Reserve High School in Wakeman, Ohio, the year after I graduated from Oberlin. And then I found out the problem in the classroom. You go too fast for some students, too slow for others. You can't tutor them. You got a textbook that's lousy. And I love the students and I love the year of teaching, but I was very frustrated by the problems that you have in a classroom teaching. And I only did it 1 year because I don't have a temporary 1-year permit from Ohio. I went back to Greencastle. I always would talk to Dr. Gass when I would go home. He was my mentor. And he said, what are you going to do now? And I said, I don't know. And he said, I'm going on sabbatical second semester. Would you teach at DePaul? 22 years old. And I said, what do you want me to teach? He said, I want you to teach the advanced theory that you learned at Oberlin that we don't know. And so I taught their advanced math classes and their professors theory they didn't know, Gödel's theorem and Cantor's method and all sorts of things. And then he suggested I go to grad school because I didn't know what I was going to do. I'm kind of an adventurer, really. I've never planned ahead my whole life. I'm just sort of like, I want another adventure. I went to graduate school at Indiana University and I loved it. It was fun. And so I stayed in grad school and 4 years later, they gave me a Ph.D. They said, now go. And then I was a professor for 7 years. And then I went into business. And I started applying practical math to business. I applied it to many different businesses and it was wonderful. And so that's what today I emphasize a student should learn practical math first, then they go on from there if they want to.
Well, then you've got it grounded. Then once you deal with the practical, you've got it grounded, and you can branch out. So,
Absolutely.
what were the origins of math as we know it today?
Well, our ancestors developed math starting with the Greeks with Euclidean geometry. Euclidean geometry was the oldest math taught for many, many centuries. And the Pythagoreans contributed to it, the Pythagorean theorem. Well, that's in the first book of Euclid's Elements, that's proposition 47. And boy, their proof is extremely difficult in that proof. And then they knew that the circumference of a circle divided by the diameter is a constant number, but they didn't know what it was. Today we call it pi, but they did not have any way to calculate the area of a circle. The Euclideans didn't. It's not in any of Euclid's books. 200 years later, Archimedes figured out a way as a precursor to what we call calculus today to figure out what is the area of a circle. It's the circumference divided by 2 times the diameter divided by 2. And then when you do a little rearrangement, that's pi r squared. You've probably heard of that.
Well, when we first started in math, wasn't it more of a practical thing? This is kind of sounding a little not esoteric, but a little more removed from the practical application, even though there is practical application to pi, obviously.
Well,
But people originally they'd weigh grain, right? And then they'd have to do fractions and have to put little weights on. Um, how did we evolve from there into these more advanced stages?
well, over the years, mathematicians would learn more things. And there's two things in math. There's concepts and there's tools. Concepts and tools. The concepts are usually pretty easy. The tools can be quite challenging, particularly if they're the old manual tools they developed. And so that went along developing all sorts of tools. And the first thing is to calculate. How do you calculate? How do you multiply two numbers together? Well, we developed manual algorithms to do that. And then we developed tools to do it. We developed logarithms and slide rules to do multiplication. Now that wasn't done until, I don't know, the 1700s. So all along we were developing concepts and tools. Now calculus came along in the 1600s. Calculus is what you have to do to analyze what are called functions. And what you need to know is what are the maximum and minimum of a function. That's differential calculus. Those tools are not too difficult. Then you have integral calculus with the fundamental theorem of calculus discovered by Newton and Leibniz. That's very difficult to apply. And that
So
looks more.
if we were to think about it, plotting a course for the shuttle, say, for instance, what level of math is required there?
Calculus.
Okay. And when was calculus developed?
1600 by Isaac Newton and Gottfried Leibniz in Germany. Now, Isaac Newton applied calculus. Back then, they had done a lot of observations, and Kepler, who worked for Tycho Brahe and observed the planets, had discovered what are called Kepler's laws, that the planets actually go in elliptical orbits around the sun, not in circular orbits. The Ptolemaic system, which had been around for hundreds and hundreds of years, assumed the Earth was the center and that everything went around in circles. Kepler said, well, wow, look at these orbits with the sun. And Copernicus came out and said, well, maybe the Earth's not the center. Maybe it's the sun. Galileo, by the way, Copernicus didn't tell that till he was dying. Galileo
So
came
all
along.
of this was figured out through mathematicians.
Oh, yeah. Well,
Interesting. Okay.
Kepler's laws were observations. He didn't know why. No idea. There's no theory behind it. So Isaac Newton knew about Kepler's laws, and he said, well, and then he got the idea of a physical force called gravity, and that involved now mathematics. There's a mathematical model. And the mathematical model, then he was able to use that to derive from the model Kepler's laws. And that's calculus. And now Newton's calculus was very difficult to understand. Leibniz in Germany had developed an equivalent version of calculus, easier to understand. And his disciples went ahead and developed it. The Bernoullis, there were three of them, then Euler, and they developed the calculus the way we teach it today.
Well, we're going to have to take a station break. Craig and I will return very shortly, so don't go away. This is Mission Evolution, www.missionevolution.org. Whatever happened to counting on our fingers and toes? With us this hour discussing math and its origins is Dr. Dell, as the author of Dr. Dell Gordon's Rule Math for All God's Children, a 21st century math education for 21st century math students. When we were ending the last segment, we were talking about the origins of math and how it related to space shuttles and everything else today. There's a lot, I assume there's a lot we couldn't do today if the math hadn't evolved like it has. Why do we work with tens? Is it because of our fingers and toes, or why is math based on tens?
Well, I would assume so, because you can have a math system to any base. The binary system is base 2, and that's what we use for computers. The octal system is base 8. And they do that because then the largest number, 111, which we would call 7, then it comes 100. Then there's the hexadecimal system. But the digital system, the decimal system, based on 10, and I'm assuming it's because of our 10 fingers, and our ancestors developed then. Now remember, there's other math systems. There was the Roman numeral system, which is very difficult to do arithmetic with. Somebody invented the decimal system, and it became easy to come up with algorithms then to do multiplication and division.
I find it fascinating that algorithms actually started with math problems rather than computers.
Well, yeah, there was no computers back then at all. They had even no idea of that, and and that's what I call. I said we have concepts and we have tools. An algorithm is a tool. So all right, you can learn to multiply 3 times 5. You just add 5 to itself 3 times, 15, or you add 3 to itself 5 times, 15. But what do you do if you got 3.25 times 6.9? Well, there's an algorithm. It's a manual algorithm, and I had to learn it. We all learned it with pencil and paper. By the way, there's lots of algorithms, but the one that we were taught is probably the most efficient one. Although they've come up with some new ones today in the new math, it's just horrible. But that's another story. But they're time consuming, and multiplying large numbers would take a lot of time. So then they developed something, and I think in about the 70s called logarithms, and they could use logarithm tables to do multiplication more efficiently. And they developed something called a slide rule, which was basically log tables to make it easier to do multiplication. That was a tool. Call that an AI tool, augmented intelligence. You could take that slide rule, and an engineer could do multiplication quicker than you could do it, or anybody could do it with a pencil and paper. Then in 1972, the first scientific calculator came out, and that changed everything.
I do remember that, believe it or not. So, what technological changes have we recently seen, calculators included, that
Well,
are impacting math education?
what I do when I teach a student math, in math is the number system. You got to learn numbers. You got to understand the decimal number system. Our ancestors invented it. It's a wonderful thing. And it lets you do things with numbers, add them, subtract them, multiply them, and divide them. But the old manual techniques are time consuming and difficult. And so the first thing I teach them to do is to take a modern calculator, the TI-30XA, costs about $10, much better than the original one that came out 50 years ago. And I teach them how to do all the arithmetic they're going to do for practical math using that calculator. And students love it. It's easy to do. And I call that an augmented intelligence. Now you take this calculator and you do all your arithmetic calculations.
But I've got a question. I got a question. Go figure. If you're having the students do it with a tool versus manually, what happens when we don't have a tool?
Go buy a tool.
Well, I'm saying, you're out in the middle of nowhere and your tool breaks. Then what?
Well, you're probably, if you're out in the middle of nowhere and your tool breaks, you're probably not going to be worried about math. You're going to be worried about survival. The bottom line of it is it's not practical to use manual tools. It's like if you got your car and it breaks down somewhere, what are you going to do? Get a horse and buggy? Because the old manual tools are horse and buggy.
What strikes me is that we're creating a generation, if this is the way we're going, we're creating a generation that can't do simple math, and they rely on
You're wrong.
a tool.
No,
Okay.
you're wrong.
Are you teaching them to do simple math?
I'm teaching them to do the concepts. I'm not teaching the old manual tools, which no one will ever use and no one will pay you to do. And by the way, there's calculators everywhere now. You got them on your smartphone. You got them everywhere. If you can't get access to a calculator, you got bigger problems than doing math problems. Believe me, you got problems with survival. So if I take away your smartphone, just think what that does to you. You use your smartphone all the time to go places, do things, talk to people. I mean, it shouldn't even call it a smartphone. They should call it a computer, which it is. Just happens to be you can do phone calls with it. But no, learning. Look, the manual tools for math are like horse and buggy math. It's like old manual tools for carpentry. Have you ever studied manual tools from the 1800s to do carpentry? Go to a museum. You don't even know what they are. You wouldn't know how to use them. They're hard to use. They're hard to learn. And so if you didn't have your modern carpentry tools, would you build a house with the old manual tools? I don't think so.
Well, if you didn't have any other options, you certainly would.
Well, then that's your problem. You figure it out. If you want to learn all the old manual tools, just in case you can't use modern tools, be my guest. I won't do it, and I won't teach it.
So again, my question is, learning the manual tools would, I assume, help one understand what the tool is doing for you. Doesn't it
You're wrong.
help you understand?
You're wrong. The old manual algorithms don't teach you anything. You have to memorize them and do them. They don't help you understand the concepts. As I said earlier, there's two things. There's concepts and tools. You must understand the concepts. The old manual tools do not help you understand the concepts as much as the modern tool does. The modern tool will help you understand the concepts much better than the old manual tools.
Okay, so are you saying that basically we don't have to learn math that like we did when you and I went to school or when your
Correct.
uncle was was
Absolutely.
was educating you? What level of math do we need? Do we need to know how to add, subtract,
Of
multiply, divide?
course.
Do we need those things?
Yeah, and you use a calculator to learn it. First, you learn what the meaning of addition and multiplication and division is. And you learn that with whole numbers are easy to do. If I tell you to take 15 divided by 3, you need to understand manually and say, okay, that's 5. You need to learn the multiplication tables. And the calculator, by the way, is better than flashcards to do that. I use a cheap calculator for young kids to teach them to do the addition. I think you need to learn the addition table and the multiplication table. And you need to understand division with whole numbers. And by the way, a lot of the tests they give today, if they don't let you use a calculator, they make whole numbers so it's easy to do. But in the real world, you don't have whole numbers. You have 3.92 and 7.8. Now, manually, that's difficult. That's where the tool comes in the real world. So, yeah, you should learn the concepts, but not the old manual tools that don't really add anything to it. There's a manual tool, for example, often you have to take square roots. There's a manual tool for taking square roots. I taught it many times years ago before we had calculators. The other day I went and tried doing it, I couldn't remember it, and I've taught it 20 times. But it doesn't teach you anything about square roots. It's an algorithm you have to learn to do.
Okay, so it doesn't go to the principles. It's just a method, a tool, an outdated tool to hear, right?
Correct, correct.
Okay. So, what math should a non-college bound student learn?
Well, the first thing you learn to use is a scientific calculator to do the things on it you need for practical math. Then what I would teach them, what I teach my students, non-bound or whoever, it's basic, practical algebra, practical geometry, and practical trigonometry. Those 3 subjects together. And it's a total of, once they've learned to use the calculator, it's a total of 36 lessons, and they learn it in about 3 or 4 months. Done.
And so you're cutting the time by using the calculator, um, so they don't get bogged down in the algorithms, right?
And that's correct. And in the regular math course done today in our high schools, they teach a lot of old obsolete manual tools that are hard to learn, and they teach theory that you'll never use. So I only teach the things you need for practical math. In algebra, when I teach practical algebra, it's only 10 lessons. Now you take a 300-page algebra book, those 10 lessons are buried in it, but there's also buried with 100 other things you'll never use. So for example, I don't know how much math you or your audience knows, but you all have probably taken algebra, and you probably had to learn the quadratic formula to solve a quadratic equation, right? You remember learning that?
No.
Well, you'd learned it. If you took algebra and passed it, you had to learn the quadratic equation. And the point is, you've never used it. So I don't teach it in the practical math, in the practical algebra. You probably learned that the square root of 2 is an irrational number. But you don't care. No scientist cares. No engineer cares. Irrational numbers are only of interest to theoretical mathematicians. So I don't teach that to beginners. So 90% of what's in an Algebra 1 book is no good. Shouldn't be there.
And it's confusing, I would bet.
Oh, absolutely. Very difficult.
Mm-hmm.
And then what happens is I take out, now algebra is a tool that you have to apply to something. By itself, it's no great value. So I apply it to geometry. I have 19 lessons, and the question is, what I teach in geometry, how long is something? What is the area of something? What is the volume of something? I'm not proving a lot of theorems. I do some heuristic arguments, they're called, but I don't do formal proofs. That's premature for a beginner, formal proofs. And then the problem you have now, you can do an awful lot of practical math with algebra and geometry. What you can't do is deal with angles adequately. You need trigonometry. It scares most people. I'll bet you never took trig. Maybe you did. A lot of people never took trig. Guess how many lessons it takes for practical trig? Because of the calculator, you can learn practical trigonometry in 7 lessons.
So when the average student, as they graduate from high school, the math that they've learned, is it really applicable to our modern world, or is it in the dark ages?
It's not applicable to anything, and the reason is they haven't learned what they need to know to be applicable, and they don't, and the stuff they don't need to know is just confusing. And so most kids that graduate from high school today don't really know math that's worth much of anything to them. They do know the number system. Usually they can do that, and then they can start applying that to spreadsheets, and they can learn accounting, then take an accounting course, maybe take a statistics course. At Indiana University, they teach something called finite math. It's a horrible subject, but that's required. But the bottom line is our high school graduates today don't know the math they need to know, because what I started to tell you was the practical math is the foundation. And it only takes 1 semester to learn that. I have students that start when they're 12 years old, and they've been through the practical math time they're 13 years old. And they know more math than 95% of all the high school graduates today. They know more math than you do, guaranteed, because they know practical math and they know how to do the calculation. Now, if they're going to go to college, they need some additional math to pass the SAT. I teach that in what I call Tier 3, and now I'm teaching it more like they do in high school. I'm using the best math textbook ever written for high school that no one's ever used. George Simmons wrote it, called Pre-Calculus Math in a Nutshell, 119 pages, $20. And now I teach you a lot of math you need for the SAT. For example, I teach the quadratic formula, because you got to know it, and things like that. I tell the students, if you're not going to science and engineering, I'm going to teach you stuff you'll never use, but you got to know for the SAT.
Well,
Now,
it's time for us to take another station break.
and you'll love
Craig
the
and I
next.
will be Craig and I will be right back to continue our discussion. So stay right there. This is Mission Evolution, missionevolution.org. What math education do we really need? This is Mission Evolution, missionevolution.org. With us discussing the evolution of math education is Craig Hane. His website, craighane.com. Craig, we were just talking about what math we really need and what math we really don't need. And from what you've said so far, it sounds like, people spend a lot of time learning things they don't need and getting confused in high school and even probably in college. And your solution for that is?
All right. Well, I'm talking high school math now. The first thing they need to learn that we talked about in the previous episode was practical math. And they can learn that about 1 semester. Now, it's self-paced. The way I teach it is all online, tutorial videos from Amazon Web Services, notebooks and exercises and that sort of thing, and quizzes to make sure they got to climb the ladder. You can't, part of pedagogy, I have what I call spike pedagogy, self-pacing, proper content, interactivity, keeping score, and empathy. You make a lot of mistakes, by the way. When you make mistakes, that's like a sport. That's good. You learn from your mistakes. In any event, once you learn practical math, if you're going to college, you take Tier 3. I told you about that earlier in the last one. And it really is more like what they teach in high school now. And I teach the things you need so you do go on the SAT. Now, if you're not going into science and engineering, then you're done. And by the way, if you're not going to college, the practical math is all you need to go into a good technical job or go to the military. When you learn my practical math, you're ready for the military. You're ready to go to a tech school. You're ready to go to a company that wants to hire technical people because you know the math you need to learn the technical subjects, hydraulics, pneumatics, electrical, whatever. Now, Now, let's say you're interested in science and engineering. Now you need trigonometry at a much deeper level. You need algebra at a much deeper level. And then you need calculus, and then you need differential equations. Okay.
So
Manually,
you're saying break it down to where you only take what you need when
yes,
you need it.
yes. Now,
Okay.
let me tell you about science and engineering, STEM, they call it, STEM. A tool came out. The old manual tools to learn trigonometry at a deep level and calculus were very difficult. It was a barrier. Most students would give up going into science and engineering because they were too difficult. The manual tools are difficult. When I taught in engineering school for 4 years, integral calculus 2 flunked more kids out of engineering school than any other subject. Very difficult manually. Now, in 2009, listen to this, everybody, a tool came out called Wolfram Alpha that revolutionizes how you learn and do math for science and engineering. Came out in 2009. That's what I start teaching then in Tier 4. I now go into trigonometry at a much deeper level, and algebra at a deeper level, and complex numbers, and analytical geometry. That's all called pre-calculus. About a year to go through that with Wolfram Alpha. Without Wolfram Alpha, it's extremely difficult and would take 2 or 3 years. With
So
Wolfram
have the general public schools have their teaching methods evolved with the time and the new tools that we have?
no,
Okay, and what detriment is that to the student at this point?
they're not learning the math they need to know. I have a student, for example, in Florida that went through my 6 tiers. And by the way, in Tier 5, I do calculus. You learn both differential and integral calculus, which is 30 in one semester, because of Wolfram Alpha. Without Wolfram Alpha, with the old manual tools, it'd take a year and a half. They don't even, differential equations are the workhorse of science and engineering, and they don't even teach them in high school. They can't get that far. I teach it now because you can learn it in one semester because of Wolfram Alpha. Wolfram Alpha changes everything. It's like going from a horse and buggy to a modern automobile. Use an
And
analogy.
and
Okay.
yet we aren't evolving
Well,
to
the
the rate
schools aren't. The schools aren't.
the schools. That's what I mean. Our school
Whole
system
school,
isn't
whole.
evolving. Our school system isn't evolving with the tools that we
That's
have
right.
at hand.
That's
And
right.
so what challenges does that leave the modern math student with?
Well, they have to take it outside their school. I have a lot of students come to me that are going to regular school, take my program on their own time, and then they know more math than their high school math teachers do. They can do stuff that their math teachers can't do because their math
So
teachers haven't been taught. It's not the math. The math teachers, by the way, are victims of it too.
I would think, yeah.
I
I mean,
wrote
they can only teach what they were taught.
another book I give away for free, just like the one you mentioned, called "How and Why Public School Math is Destroying the USA." I give it away
So
for free and explains all this in great detail.
so why do so many students struggle with math at this point? I mean, we've been teaching math forever.
They've always struggled with it because the manual tools are difficult. They've always struggled with it. It's nothing new. They've always struggled with it. I was the only student in Greencastle High School, to my knowledge, was saved by Miss O'Hare and by Dr. Gass that went ahead and got a Ph.D. in math. I'm the only student that I know of that ever did that from Greencastle High School because they were victims of the high school math and they gave up. They didn't go into math.
So weren't also the math teachers victims of the old
Yes,
math format? And
yes,
so that thus you ran into the gentleman that said, "Don't ask me questions like that.
that's right.
Just learn just learn the tools."
So
But he couldn't answer the questions. Is that what
that
was going on there?
yes, that's correct. He didn't. That's right. Let me give you an example. Algebra 1, people talk about Algebra 1. There's the big, thick Algebra 1 book. It costs a lot of money. If you have 10 different Algebra 1 courses taught by 10 different teachers, that'll be 10 different classes. None of them will be the same. The teachers teach what they think they can understand and teach. They don't understand a lot of the stuff that's in those books. So they teach what they know. And they teach what they think they can teach. And they tell them, memorize this, do this. It's horrible. If you ask me what is Algebra 1 in high school, the answer is it could be a lot of different things. Depends on what the teacher is going to do. I had a teacher that was terrible. Now, if I'd had a good algebra teacher, and there probably are some, like Dr. Gass he was a teacher at DePaul University. He was teaching me, by the way, basically Algebra 1. was called college algebra, but you have to start at the beginning. And so, but he was a good teacher, but he was a Ph.D. and he was a chairman of the math department at a college. He wasn't a high school teacher. And
So how do let's go to college now. How do these teachers get all the way through college and supposedly be able to teach math when they don't know what's in the textbook? They don't understand it. How does
well,
that
I,
happen?
I, I explained that in my book called Public School Math. It's called The Horrible Curve.
Okay.
That's the reason.
So
Here's why. The way they grade students today in high school and in college is they give them a test where they score different scores, and it creates a Gaussian curve. They call it a bell curve, and they give the upper 10% A and the bottom ones Fs, and then the middle ones get Cs. Anybody that isn't in the upper 10% probably didn't learn math. They just learned enough to pass a test, and they're very good at making up these tests. These SAT tests are horrible. They don't prove a damn thing. They're terrible
so
tests.
so if we back up just a little bit, it sounds like we're learning to pass tests. We aren't learning to have the skill set. And
Yes.
so our whole school system right now has
Yes.
these tests, ACT, I think they are. So the student has to score for the school to get funding,
Correct.
but it's not really teaching the student anything outside of how to pass the test.
That's exactly right. 100% correct.
Goodness. So how can we turn that around in the school systems?
I don't know the answer to that. I think the answer is going to be the new AI tools are coming out, the new ones that based on large learning models. For example, I'm beginning to use now Gemini, and Gemini is amazing what it'll do. I believe that we will have AI tools in the future, not today, that will be able to teach these subjects in a very appropriate way, very effective. And I think that the teachers that are now teachers will have to become coaches or something. I think the schools, if we're going to succeed, and for example, right now we're trying to rebuild a lot of companies in the United States, but we don't have workers that can even do the. Uh, Nobody knows. I mean, how do you? And people say, well, why haven't they changed? And the answer is money, honey. They got all these textbooks, or $1 billion textbooks, every high school math textbook is obsolete. Now, your math educators hate my guts. Well, no, you're wrong. We're doing a good job. Buy our textbook, take our tests.
Well, the bottom
Homeschoolers,
line is
ho-
the bottom
home,
line is we're crippled. Okay.
yes, yes,
And so
yes,
it looks like it's snowballing downhill in that. So the math teacher doesn't learn math very well, so his students learn it even poorer, and then their
that's
students, and downhill we go.
that's
How
correct. But
long before rock bottom when we decide, okay, this needs to be revamped, this needs to evolve?
well, I don't know the answer to that. Nobody knows. You can't predict the future. But the new AI tools that have come about just in the last few years are amazing. Now, by the way, Wolfram Alpha is what I call an augmented intelligence tool, but it's not based on a large learning model. It's a mathematical program, and that's another story I won't get into. Explain in my books, but the new tools now, like I'm just absolutely blown away by Gemini. I haven't tried Grok yet, but they say Grok 4 is incredible. I want to try it. I've tried a couple others I don't like. I won't get it. I don't want to say, but I think that the new AI tools are going to revolutionize education in ways that are unavoidable. Now, how long it's
Well,
going to take, I don't know.
we could
It's
use
kind.
some revolution in the system, no
Here's a
doubt.
here's a question for you. How soon are we going to have automated driving cars where nobody ordinary, you don't drive normally, you just get in an automated car and go? How soon is that going to happen?
Well, they keep moving the singularity up too, so who knows?
Well, that's right. Ray Kurzweil. We don't know. Nobody knows. And but it's coming fast because we're on an exponential growth curve, and it's coming fast.
So
But having,
what kind of a learning curve do these new AI tools have
I'm
for
not
the
sure what
person that's u
I don't
the
understand your
person that's
question.
trying to use them? How difficult is it to learn to use these new AI tools?
Not very difficult at all. Very easy. Now, it's like any other thing. You need somebody to. Here's the question. Wolfram Alpha is an AI tool. It's automatic intelligence. But if you don't know the concepts to ask it the questions, it won't answer them. So you've got to understand the concepts so you know what right questions to ask. I mean, if you don't
So that
understand
takes us back to having the concepts taught in math.
concepts are critical. But here's the thing. The concepts have always been easy. On my website, craighane.com, I have a video library, free videos. I have 3 videos that take about 1 hour to teach you the concepts of calculus. The concepts, not the tools, the concepts. The concepts of math are pretty easy. It's the tools that traditionally have been very difficult, and the new AI tools are making it very easy.
Well, I'm hoping it's getting easier, right? I'm sure everybody else out there does too.
It is for sure.
Yeah.
I have hundreds of homeschool students that are doing it now, and I've got rave reviews, and they all, yeah, it's amazing. There's no question about it. The problem is what I'm doing would revolutionize what a current school is doing. First of all, no textbooks, they're gone. And the teachers aren't teaching it. They're not getting up and lecturing. They could become coaches. I'm the teacher, and it's all automated. It's all videos off of Amazon Web Services. It's not me doing it personally. And they don't want to change. When the scientific calculator came out in 1972, I was teaching in engineering school. And when it came out, I saw what it would do. And I told my fellow faculty members at Rose-Hulman Institute of Technology, I said, look, what you're teaching now with log tables and trig tables and slide rules is all obsolete. They thought I was crazy.
Well, crazy or not, it's time for us to take another break. Please stay with us. Craig and I continue by exploring the esoteric aspects of math. This is Mission Evolution, www.missionevolution.org. Does math hold the proof of God? This is Mission Evolution, missionevolution.org. We're continuing our discussion with Craig Hane. His website, craighane.com. Craig, as you can tell, we're going to change gears a little bit here. You said some things that kind of fascinate me, and that's the esoteric aspect of math. And does math hold the proof of God?
Well, science and math together do, in my view. Now, depending on how you define God. To me, God is something beyond human. It's not physical. And we don't know what it is. We don't understand it very well. It's just something exists. And the reason is, it goes back to the origin of life. Today, our science is such that we understand a cell, the simplest form of life there is. It's such a complicated factory with DNA code and all sorts of other tools. There is no way, if you just look at it analytically with probability theory, that this could ever just sort of come about by random action. So something created it. And whatever that something was that designed it, and we don't know how they did it, by the way, but whatever it was, that's what I call God.
So the creator.
Creator.
Okay. So are you saying that simply because when we do theory, when we do probability theory, there we go. When we do probability theory, it proves that the cell could not have been a big bang or a happenstance. And so is that the proof of God you're talking about?
Yes.
Okay. So if indeed God created the cell, when did God and why did God create math? And is math a representation of the way God works?
I don't know. But math, first of all, you have to know what math is. Uh, mathematics actually consists of undefined terms, assumptions about them, which are called axioms, and theorems, which we then prove with Aristotelian logic. And there's an unlimited number of axiomatic systems. We've discovered a few of them, or created them, or discovered them, and we've proved a few theorems. That's all we've done. And then we take the mathematical system, and we apply ostensive definitions to the undefined terms. Like in geometry, a point's an undefined term, but we think of it in the real world as being a position in space. And a line is it connects the points. And the problem we have is there is no math model we can create that is identical with whatever it is we're trying to study. It's always an approximation. Newton had an approximation, Newtonian physics, but and it works great for most of the things we do. Einstein came along and said, wait a minute, space-time is different than what Newton thought. And he came up with with special relativity theory, where time varies. If you've got two watches and that are running identical, and you take one of them and you move it up 100 feet, it is now going faster than the one you're holding in your hand. That's fact. And it's also...
So we're talking about the mechanical watches or the analytical watches?
Any kind of watch.
Seriously?
Any kind of watch. If they're identical and you move one up 100 feet, it's less gravity and it goes faster. Okay. Time is determined by gravity. When you go up in the air, your time, now it's very small. We can measure it, but it's very, very small. The other thing is if one watch starts moving fast compared to the other one, its time slows down. This is what Einstein discovered in his two relativity theories. When we do GPS today, we have to make corrections. We have a watch on Earth and an equivalent watch in a satellite, and we have to make two different corrections because of those two things so they can communicate. Otherwise, we couldn't even have GPS. You couldn't have GPS with Newtonian physics. It takes Einstein's physics. That's just one example. Now, I can go to quantum theory, and we can go on and on. But our theories today are incomplete. We know that because we have two major theories. We have Einstein's relativity theories, and we have quantum theory. And Einstein's theory is great for big things and the galaxy and all. Quantum theory is great for little things. When you put them together, they contradict each other.
Oh, lovely. So are you seeing that our forms of math and our theories are destined to evolve with our understanding of the universe?
Oh, sure, they are all the time. But the question is, will we ever have a math model that somehow perfectly represents the universe? And my opinion is no.
Well, we can't conceive of the universe, so how could we build a math model that would?
Well, I know, but I'm just saying I don't think it's possible. Math is one thing. One of the problems you have with math, of course, is this whole concept of infinity. Now, and infinity, believe me, that opens up that sends you down a rabbit hole that's unbelievable. It creates all sorts of theoretical problems that clearly can't manifest in the real world. It's unbelievable. And if we had time, I would give you examples of that. But if you want to do another video sometime, I will talk about theoretical math. I could tell you all sorts of things about theoretical math that are absolutely amazing that most people have no clue of. And it's fine. They haven't learned it. Just like I don't understand music. I listen to it, but I don't understand it.
So if it's changing all the time, what about these proofs? You know, everybody's seen a picture of Einstein with these unbelievable hieroglyphics all over a chalkboard, right? And mathematical proofs are supposed to prove a theory. But if math is changing all the time, if we're evolving all the time, do those proofs become non-proof?
No. By changing, what I mean is two things. You have an axiomatic system and you start proving theorems. And there's always more theorems to prove that you haven't proven yet. In fact, there's some today that are out there that if you could prove certain theorems today, you give you $1 million right up front. $1 million, boom. Riemann hypothesis, just for example. Okay, that's within a given axiomatic system. Then you have different axiomatic systems, many of which we've not even created yet. And then you prove theorems in that. And there's no limit to how many axiomatic systems you can have. For example, if I ask you, what is 2 plus 3? I know what your answer is going to be because you're in a certain axiomatic system you use, and your answer is going to be 5. But there's another axiomatic system just as good as that one where the answer is 0. And there's another one just as good as those where the answer is 1. And they're all equally good.
But we're trained and we think in tens.
Well, you do. Scientists and engineers, in certain subjects, and mathematicians think in terms of the mod 5 and the mod 7s and all that. In mod 5, the answer is 0. So, and those are called finite. So math is a big subject. It's bigger than music. Math is a humongous subject. And so no mathematician, by the way, knows all the math. In fact, any two mathematicians could get together and one can ask the other one questions he cannot answer that this one knows, and vice versa.
So it seems like it's kind of nebulous, huh?
I don't know what nebulous means.
um, yeah, there you go. So, is there any validity to the practice of numerology if we're being esoteric?
I don't know.
You're familiar with it, though.
Not really, vaguely.
Oh, okay.
I don't claim to understand it.
Okay. And
Astrology is another one I don't claim to understand.
so, what?
Carrie Mullis thought astrology might have some meaning. Carrie Mullis, Nobel Prize winner. I don't know.
So, what do you see as physicists' big mistake?
Physicists,
Mm-hmm.
big mistake.
Mm-hmm.
Oh, Einstein assumed that nothing physical could go faster than the speed of light, and he assumed that the only thing that there would be with physical things. I believe Dr. William Tiller, remember that name, Dr. William Tiller, he created a concept that there's a non-physical universe superimposed on the physical universe. And the non-physical universe has its own set of laws, which he came up with a model for it. And that is really where God exists, probably, where your soul exists. Like today, consciousness is something people admit they don't understand consciousness. Is that just something because of the neurons in the brain? And the answer, in my opinion, it's an opinion, is that no, your consciousness is in your non-physical self, which is superimposed on your physical self. When you die physically, your non-physical self is in another. And by the way, it's not in space-time. It's in a place where time doesn't mean anything. That universe, it's a frequency universe. I think your memories are there too. I think your brain, by the way, is a receiver transmitter. I think but again, I can't necessarily prove this. Tiller's got a model for it. He's done some experiments that prove that that consciousness can do things to change physiology that our sciences can't understand, our conventional science. So I think
So,
that was a big mistake.
if we change our concepts here, does it change the energetic concepts around us, or vice versa?
Absolutely.
So,
Absolutely.
so there's the key to manifestation.
I was taught by my Sunday school teacher when I was 10 years old in Christian school that, Craig, what you believe will cause things to happen. Not what you desire, what you believe. And beliefs are hard to change. But I learned how to change my beliefs because I lived out in the woods by myself, and I would walk in the woods by myself, and I would fascinate. I would talk to myself all the time, and I believe things. And all my life, things that were highly improbable happened because of my belief. And that's happened to me time and time and time again. Now, maybe it's just coincidence, but I believe that your mental thought processes do affect your physiology. Now, for example, I'm an old guy. I'm 86 years old. Okay. I do not have any health problems. I don't take any medicine. I don't have any aches or pains. I feel like a young old man. Why is that? It's because of beliefs and what I do. I think your belief system is extremely important. If you believe you're going to get cancer, you're going to get it. If you believe you're going to have a problem with whatever, you're going to have it. On and on and on.
But
I
we
have
have unconscious beliefs that are driving our life, I take it.
I wouldn't know. I'm aware of my
They're
consciousness.
unconscious.
Beats me. Could be. Could be. Your unconscious is extremely important, by the way. When you do math, I teach that. When I focus on something in math and I get confused about it, I take a break and come back, and my unconscious has worked on it, and sometimes it helps me understand it. And mathematicians have been saying that forever. All kinds of great mathematicians said their unconscious does a lot of math that they're not aware of when they're not focused on it.
It's the old sleep on it adage, right?
Yeah.
Yeah. Yeah.
Or or go do something that's just where you're not thinking about anything. I cook my own food. I wash my own dishes. I clean my own things. I do things. I play with my children and my grandchildren. I do things that don't require any focus.
Well, Craig, I'm sorry, but we are totally out of time.
Thank you.
Thank you so much for coming on the show. Our guest this hour has been Craig Hane, the author of Dr. Dell's Golden Rule Math for All God's Children, a 21st century math education for 21st century math students. To find out more about Craig, where you can find his books and all he has to offer, visit his website, craighane.com. This has been Mission Evolution with Gwilda Wiyaka. For more information or to enjoy past archived episodes, visit www.missionevolution.org. But please be sure to join us again right here on the X Zone TV channel, xztv.ca, where this mission will continue, bringing information, resources, and support to an evolving world.